Alright, so we've learned about classes and how to design single examples of them that satisfy encapsulation. But some classes are more complicated and need some sort of hierarchical design, and that's where the true power of object orientation shows itself. Such hierarchies are designed and created using inheritance. In this video, we'll learn what it is and how to use it. Let's get started. Alright, so we've established that objects can inherit from each other in object-oriented programming. Now what does that mean? It means that given a class A, you can create a class B that inherits methods and properties from class A. It'll have the same methods and properties, but it can also have its own specific methods and properties. Let's do an example. Suppose we want to model the types of living things in a video game. For that, we create a class named creature. Now, what properties and methods are the same among all creatures? Well, they all grow, they reproduce, they use energy, they get born, and they all die someday. So those are the methods for the class. All living things that I can think of also have a physical form, so I put that as a property. Now, let's say I want to differentiate between animals and plants in my model. So I create a class for each of them, both inheriting from the first class. Now, since these two classes are both inheriting from the class creature, they automatically have the same methods and properties that we've created for creature. But the cool thing is that we can rewrite the methods and the properties of each of these subclasses to adjust them to the specifics of those classes. For example, the use energy of animals could be rewritten to consume food and for plants to do photosynthesis. The physical form of animals could be free and for plants static, because plants don't move, right? We can also add more properties and classes to each of these subclasses that weren't in the parent class. For example, we could specify a color property for plants and a move method for animals. Now we can create a further subclass for plants and animals that inherit from them, like dog, cat, and cow for animals, and tree, flower, and grass for plants. And each of those could have their specific rewritings of their parent methods and also introduce new methods and properties specific to them. So in a way, inheriting is nothing but creating a subclass that practically is an instance of its parent class, but it also extends that parent class. And in this kind of modeling, if you later on decide that you want to add a new creature into your modeling, you can do that easily by creating a new child that inherits from the class creature, and that is done. And it can again have its own subclasses and so on. So here's where the flexibility of object-oriented programming shows itself. Every object-oriented programming language that I can think of supports inheritance in one or more ways. We'll see these language-specific OOP stuff in their respective series. And inheritance is one of the main things of OOP. So everywhere you see OOP, there is inheritance in there. And it's actually the main reason that this paradigm, the object-oriented programming paradigm, is used to create big softwares. It's also used in all of the design patterns of OOP that introduce some cool, useful design ideas for software projects. We'll get to those in a later series. But for now, I hope this short video made it clear what inheritance is and how to use it. The next video is going to be about abstraction that uses inheritance and wouldn't be possible without it. Like and share this video and subscribe to the channel for further videos. I'll see you there.